So here's story about the evolution of search engines. So I remember the Yahoo directory that was done by people. It was very successful and useful when it came along, and it was essentially a hierarchically organized, rich set of information which effectively gave a tree-based answer to information categorization and search. So you searched for things which were entries on this tree and the leaves of this tree. Then we had the first generation search engines, which only use sort of effectively the text data on the page. There are various information retrieval techniques, which we will discuss, TF, term frequency slash inverse document frequency, vector space models, where we think of everything, documents and queries sitting in a space. These were capable of scaling much better than the original Yahoo method. Lycos, Excite, Inkame were early versions there, and they did not do much work on ranking, and they were relatively easy to game the system and get back to the user spam or pages where the owner of the page doctored the page to make search engines respond with that page. So then along came Google, and of course they were not they were a particularly precise formulation of link analysis. I don't think they were certainly not the first to do link analysis. And we have link analysis, which is what pages a given page refers to, and then what you're interested in was turning pages which are linked to by many other pages. We have the anchor test, which is pretty interesting. When you do a hyperlink, you have both the link and you also have the text, which is hyperlinked. So that text, which is called the anchor text, is pretty useful because it tells you what the person referencing that page actually thought about the page. So that's a sort of a very interesting additional piece of information you can use in search engines because it's very dynamic. It is highly motivated to be accurate and probably has high value added. It's not so much of it, but it's high value added. Click-through data, that's this thing about buying shoes. We want to know when you get to a page what people click on and what they do when they click on it. So the ranking today is much improved, but now we're also improving things like getting diversity so we don't have our results being too homogeneous. And there's a big, there's, as they say, a cat and mouse game where the spammers and the search engine writers leapfrog each other and trying to remove spam and trying to second guess the anti-spam device. So the next set of search engines were really trying to focus on what the user really implied, not the words in the query, and you can get a lot of value added, such you know where the user is, like when you go to a foreign country, the search engine often changes the search engine to correspond to that country. That's actually not always what the person wants, and usually they ask you if you want to change your search engine to one optimized for that country. You have the previous queries, and you can also, of course, use regular expressions to try to do a more precise matching. Then we have, of course, not just text, we have maps and videos and images and news stories and things like that. And as you type your query, there's automatic spell correction, actually automatic real-time results so that you can see whether what you're getting is what you really wanted, which helps you write a better query. And these are all ways of trying to help the user as they write the query get good answers. So now we're having an even greater focus on topics, namely the technology which were mentioned briefly, like latent deletion allocation, and those technologies are things like similar to those used in Google News, which try to focus on the hidden meaning of a document. Remember what a document was? It's something. I think web page is a document, and so another thing is the growing use of social network sites gives you a lot of context, which can help the search engine find what the user's interested in. And because we know that makes an enormous difference when you search for items at Amazon, because the Amazon will use who you link to and who has similar rankings to you to find out what you want. So here we have a new emphasis on the diversity of results. You don't want everything coming from the same website, and so you want to make certain that you give them plenty of choices. This picture here is one of what a web search engine looks like. Here we have the user issuing queries, getting results. The results are ranked, and that's what the user gets back. The query, as well as that, we have crawlers. The crawlers are going out to the web. The user's feeding back to see what the good things to crawl. We have all the data get from the crawlers gets stored in a repository. You make nifty, sophisticated image indexes. We have all sorts of value-added things here, indices added, and you then also look at collections of pages and analyze them. So this is the type of architecture of a web search system.